I'm going to try to make an attempt to show you how I'm going to mill down these flats on this dowel. This is for the main mast. As you can see, I already have the tree made, and I already know the dimensions of this inside here. It's going to be 7.93 millimeters. Now, this tip here that I put on the lathe, that's where your cap is going to go. And anyway, we know that wood is not perfect. If this were a rod of brass or steel, that we can really get down to the thousandths and 10,000ths. But since this is wood, we're not going to worry too much about these smaller amounts. We're going to round all that off later. And besides, when we get on the mill, we're just going to do a little bit at a time until these flats will fit into the tree. So how I calculated this was, this is not to scale, but the dowel is 12 millimeters. As you know, if you were to take the calipers and go around, you may get 12.05, 12.1, 12.2, but that's okay, we're not worried about that. Basically, in order to do a calculation, I just want to get a rough estimate. So we have 12 millimeters, and the dimension of the flat from flat to flat is 7.93 millimeters. So what we do is we take the 12 millimeter, we subtract it from 7.93, we come up with 4.07. Then we take the 4.07, we divide it by 2, which gives us 2.035. Now I know that when you're dealing with wood, it's just no way to get down to 35 thousandths of an inch. That's ridiculous. But we had to do a calculation to see how we're going to do. So what we're going to do, we're just going to mill down a flat from here to here, roughly a little bit under 2 millimeters, maybe 1.97. And then we will flip the dowel around, and we will do the rest of the sides. So anyway, this is basically the beginnings of how to mill flats. Now the instructions call for, from this distance here to here is 75 millimeters in length. So we're actually going to cut a flat all along here. And stay tuned, and we will take care of that. And we're starting where I left off with the calculations of the mast head. And here you'll see that I have the mast that's mounted on the mill. Very flat surface. You really need a flat surface. And the particular end mill that I'm using here has got 4 flutes on it. Some have a single, some have a double. This has got 4 flutes for a nice smooth cut. Now before I go any further, before I forget, I want to mention that I took an X-Acto knife and I scored where the end of the dimension is supposed to be, which is 75 millimeters from the cap to where the tree will rest on. And the reason why I want to score that fairly deep with an X-Acto, because as the mill goes through, when this turns in this clockwise direction, these little flutes would dig into the wood. That's what you want. It will not splinter. But as this goes forward through like this, when it gets to the end, it will try to splinter and kick out, because this is wood and that's just the nature of things. So what I did, I thought about it, and I just took an X-Acto knife and I just scored the opposite side fairly deep. So that should, and I hope that it will avoid any splintering. So what I want to do, and I'm really reluctant about making these videos because I'm afraid that I might leave some information out. But I want to just talk about this mill here. For those that do not have one, that want one, or maybe you have one and you haven't used it much. You know, there's a lot of material out there on the internet. There's books. And it seems like that there isn't one book that's going to cover everything that you need to know. I just want to run over just a few things. This right here is a metric. It also comes in imperial inches. This particular model is metric. It's a 5410. And you can go to Sherline.com, and they have just a basic model 10 inch. The 10 inch refers to the X length. And I think that model is just shy under $700. However, you do not get any accessories. They just give you just the bare bone mill. However, you will need some accessories because this is a milling plate. It's nice because it attaches to your X here. And you have these hold down blocks here. And you have these little special hold down angle brackets. These are really meant to hold down the Sherline adjustable vise. Okay, welcome back, and we're going to see if we can cut our first flat on this stock. And before I begin, I want you to take note that I have the Z coordinate, which I think the British and other countries call it Z, Z-E-D, which has its origins with the Greek letter Zeta. I think the French took over that and called it Z, Z-E-D-E. In America, we just call it Z, Z-E-E, Z for short. Anyway, that's your Z-axis going up and down. What I have here is where the mill end mill is actually starting to touch. I have my Z-axis set to 0, and I also have my Y-axis this way set to 0, so I always have a reference point. So let's go ahead and see what happens. Just get started. Now, one thing I meant to mention is the fact that my end mill is roughly about half the diameter of the stock. I don't know why I chose that. It's just a happy medium that I found that works out pretty good. So let's go ahead. We're going to lower the Z-axis. Let's just try an initial cut of about maybe 0.5 millimeters. Okay. And let's go down to about 1 millimeter. And let's go ahead and make it 1.5. And finally, let's make it about, I think earlier I said I was going to try for 1.9. Okay, let's see what the cut looked like. And it looks really well. The little X-Acto knife cut did help. I don't have any frayed ends on that side. So now what I want to do now is move the X table back and forth, and we can go ahead and flatten this thing out. But I don't want to use the same depth. I want to go back up to where I was. Okay, we're going to make a first cut at about 0.5 millimeters. And I have the mill where some of the cutting edge is off the stock and the other half of the mill is on the stock. Okay, that was a rather shallow cut, so let's go ahead and plunge it on down into the stock a little bit more. Let's go about 1.2. Okay, we're going to use our y-axis to go into the cut some, and then we're going to work our way back down. Move our y-axis table over some, and then finish up the cut. Okay, let's go ahead and lower this down to about 1.9. And just start cutting across. Then we're going to adjust our Y table to come back and just work our way back. And come back just a little bit to get this little bit of an edge. Okay, so we did an undercut because I'm probably going to come back and finish that off. I don't want to overcut. So as you can see, we really have a nice clean edge right here. And that is it. And next time I'll show you how we're going to cut the other flat. And what I'm going to do, I'm going to use a shim stock, something like this. And what we're going to do, we're going to turn this stock with this flat side. Flat side is going to rest on this, and then this will get secured to this aluminum plate. The reason being is because obviously 180 degrees opposite of this is flat. This is now our new reference. Whereas before we didn't have any reference, but now we do have a reference. This will be turned around on a flat surface, and we can mill the opposite side of this. Stay tuned. Okay, as you can see, I decided to use a little bit different block height, and with this flat, we're going to place it like this, and of course it butts up against this edge, and then I'm going to mount my hold downs, and hopefully I will have some screw holes that are in a convenient place to put pressure on this to hold it in place. Okay, so it seems like that I got everything set up. Just like I said before, the setup always takes longer than the actual cut. We don't want this stock to move. We don't want it to move in place. So in order to do that, is you remember this cap cut with the lathe, there's just a little bit of distance between, or a gap between, the lower part of this cap piece and this stop holder. And yes, I did change that up. I was going to use a thinner piece, but I decided to use this heavier piece. So it just so happened that this rule here just so happened to slide underneath that to apply a good pressure, because I don't want this to bend or break. I'm not really applying a lot of pressure here, but it is enough to hold it down. The same on this side over here. I used a rule, and I used a gauge set to help elevate this up to where it just does kiss this bottom, or touch this bottom dowel, and I cranked that down until it's nice and firm. So that means we have tightness here, here, throughout the entire plane. So now we can go ahead and mill out the second flat, which is on the opposite side. And if you notice that on my digital readout, you'll see that the Z reading is at 0. That's your up and down, and your X and Y. This just zeroes everything out. So I know you don't have to really go through all this much trouble. I guess because I have the resources available is the reason why I guess I go ahead and do it. Now on a thinner, smaller dowel, you probably don't have to go through this much trouble. But it does have to go up in that tree top. So, okay, so let's see what's going to happen. Go ahead and turn it on. We're going to go down about 0.5 mil. And you can look at the digital readout, and you can see as I go down to right at 0.5, we want to start our cut. Okay. And we'll go down to 1 millimeter depth. And by the way, I did use the X-Acto knife to make this cut on the other side so that the wood won't fray or splinter. Okay, let's carry it on down to 1.5 millimeter depth. Okay. And let's just go ahead and work our way across. Use the y-axis here, and we're going to go back the other way. Okay, I'm just going to plunge on down to about 1.9. And since I have my X was zeroed, I can look at my digital meter there and put it right on 0. And now I can work my way back across. Okay, so now let's we're going to do a little measurement here, and then we'll take this down. I'll come back and take some measurements. Okay, so we come back and we're going to measure this flat. You can see it's 8.13 millimeters. And I think we're satisfied with that. I went back and measured the tree for squareness, and it's not exactly perfectly square, but this is a good start. As you can see, we have a nice symmetry there. And so let's get set up. I'm going to mark this as cut number 2 right here. Okay, we'll come back. Here's the important thing. All of these settings here will have to go away, because what are we doing? This part of the dowel is flat. So what we're going to do is put this straight onto the work surface, just like that. Okay, so be right back. Okay, now we're back to cutting out side number 3. We have one of these is side 1 and the other side is side 2, and we have both of those sides now have a flat, of course, and they are compressed with these little blocks of wood to help facilitate holding everything. We have our hold down blocks, our shim here, etc. So the same routine. We got everything set to 0, and we have got everything set to the line. Take a X-Acto knife here and mark off this little area. Seems like it's already been marked. That just keeps the wood from fraying and splitting splinters. Okay, so we're down to 0, and we're going to, like we did last time, we're just going to start with a .5 cut. Almost there. Okay. So I'm going to lower it down to 1 millimeter even. Now 1.5. And then finally about 1.9. And we go ahead and use the X-axis table to go ahead and cut this off. This time I'm going to go ahead and just cut the full depth. Okay, So there's our third cut. Go ahead and mark this as number 3. All we have to do now is disassemble our hold downs, blocks, jig spacers, whatever, and flip this around for the last time. Okay, so here we are again, and we are finally going to cut our 4th flat. And what we have here, it seems like that number 1, the first flat is on this side, the second flat is on that side. You can see the number 2. The third flat is on this bottom, and of course we have the block here and the stock butted up against here, and we have the shim so that this pressure won't make this crack or be in a strain. We have this parallel bar here just as a space to help hold the pressure. So have a nice and firm hold on everything. I've already got the Z-axis set up for a 0.5 millimeter cut. We're going to do it like the others at 1.9. And now we're just going to use the X-axis table to make this cut down here.